Okay, I guess before we start, I want to point out two things you got. You got the syllabus for this unit. There will not be a test for this unit. There may be a quiz, but if there's a quiz, I will announce that to you ahead of time. I also gave you the review, so if you want to get started on the review, we'll talk about that more later, but I wanted to give it to you in case you want to start working on that. Today, we're going to start talking about light. And specifically, I want to talk about the basics of what light is today. I'm just going to see if they can see it on here. Oh, yeah, they can. Everyone say hi to 7th period. Hi.
Sorry, we couldn't talk about that. They missed me.
What's going on? All right. So we're going to talk about light and specifically what causes light. And so to do that, I've got a couple demos here. And actually, Kendra, this is where you could help me because I'm going to do other things. So, all right, I'm going to go in the front.
This is going to be a wonky video.
So, just to connect light with what we've been doing. So, what I got here is just a voltmeter. So it's going to measure how many volts I have in my circuit, which right now is nothing. And one of the things you can talk about, so we did in the electricity unit, we did all of our electricity, all of our voltage, our potential came from the battery. But that's not the only way that it can come from. And so the way electricity is generated is you can take a magnet and you can move it through a coil of wire, and if you watch that, right, as I move the magnet through the coil of wire, you can make a voltage, right? And so that's sort of in the end, that's how all electricity is generated, is by moving a magnet through a coil of wire. So one thing that can happen is you can take magnetic fields and you can use them to create potential. You can use them to create magnetic fields. Hi. Thank you. All right. So so there's that. You can use magnets to create electric fields. Now, the other thing that maybe you've seen before is if I have a wire and again I put it in a coil. What? You can't see it? There you go.
They all sit in that.
Okay. So, you can use magnets to create voltage. You can use magnets to create electricity. We can also do the opposite. So this is a coil of wire wrapped around a metal rod. This is a regular metal rod. There's nothing special about it. Specifically, there's nothing magnetic about this metal rod. But if I hook it up to a battery so that I have an electric field running through it. All right, hey guys. All right. If I hook this up so that there's an electric field running through it, I can turn my electric field into a magnetic field that I can use to pick up these paper clips. And I know that it's the electricity making the magnetic field because if I stop the electricity by disconnecting it, the paper clips fall off. All right. So, what we've got then is we've got that electric fields can make magnetic fields in certain situations. And in certain situations, magnetic fields can make electric fields and electric fields can make magnetic fields. All right. So why is this important? Well, the fact that you can go in both directions makes possible something that's called an electromagnetic wave. And the best example I have of an electromagnetic wave is a radio wave. So a radio wave is usually generated, you've got a big antenna, and you take the electrons in the antenna and you push them up and down, And what happens is you have a moving electric field, and what can moving electric fields make that we just talked about? If I take electricity and I move it around in a circle, I can make a magnet. So what happens is if I have a moving electric field, I can make a magnetic field, which I'm going to symbolize as this way. So I start with an electric field, I use that to make a magnetic field, but now I have a moving magnetic field, which makes what? Moving magnets make electric fields. And then I have a moving electric field, which will make another magnetic field, which will make another electric field. And so what you get is this thing called an electromagnetic wave, and a radio wave is an example of electromagnetic wave. And all it is it's moving electric fields, making moving magnetic fields, making moving electric fields, and it's this wave that's going back and forth between electricity and magnetism. So at the core, this electromagnetic wave is a wave that follows all the characteristics of waves that we've talked about before this point. All right, thanks. I'm going to